With the University of Arizona being situated in the Sonoran Desert where sunshine is abundant year-round, it's only fitting that the first episode in our monthly Project Sage series on sustainability focus on Earth's most abundant and underutilized resource for creating energy, the sun. One current project underway at the UA's Energy Frontier Research Center is the development of the next generation of solar cells.
The general thrust of the work is to try to understand the chemistry and physics at the nanometer level for Generation 3 solar cells. These are the most exploratory solar cells that have been developed to date. Their efficiencies are not good enough for them to be commercialized yet, although we're close. But they also offer the promise of the lowest cost electricity generation of any of the solar cell technologies that are on the boards right now.
Current solar cells work by utilizing inorganic materials such as silicon as a semiconductor, but the cells are expensive to produce. But the new cells are being developed with the goal of solving problems associated with existing solar cells.
These are representative of the kind of cells that we're currently making in the group, and as you can see, they're fairly small. There are typically 6 cells per chip on this slide. We might have others in the group that are maybe 25 actual solar cells. Those are very small devices. They have to be small at this point because we're primarily using these in a research environment. Now the next step up from that is a cell which looks a bit more like this. And here we have actually 3 cells right next to each other, and they're substantially bigger. They're starting to approach what the commercial technology would look like. There's little stripes that are maybe 4 or 5 millimeters in width, and then they can basically be as long as you want them to be.
The goal is to utilize organic compounds and dyes so that the solar cells can be thin and flexible enough to cover a house or a car, or to power portable electronic devices.
And then the new challenge is you guys are going to want this to sit outside on a day like today and get extremely hot and generate electricity at very high efficiency and not degrade and not cost very much. So those are big challenges. Those are challenges of technology, but they're also challenges of basic science. And that's what the DOE Energy Frontier Research Center program is all about.